Let's go ahead and see if we can solve this exponential equation that involves a couple e raised to powers. So to get started on this, what we want to do is think about getting everything on one side by itself, and then 0 on one side by itself. So the first thing I'm going to go ahead and do is subtract that 6 and move it over to the left-hand side. So that'll give us 0 on the right-hand side. The next thing I'm going to do is go ahead and think about this as this is an equation of the quadratic type. And what I mean by that is I can rewrite this so it's e to the x squared for that first term minus 7e to the x minus 6 equals 0. Of the quadratic type means that that first exponent is double whatever that second exponent is. So we have e to the x squared and then e to the x to the first power. Okay, so it's of the quadratic type. Now, a lot of times how we try to approach these is we try to approach them by doing a quick substitution. This makes it look like something we've seen in the past, and I know it's kind of strategically just rewriting this. So wherever I see an e to the x, looking right here, I'm going to replace it with a w because of my let statement. So instead of e to the x being squared, we can say, well, that's the same thing as w being squared, minus 7 times, instead of e to the x, we can put a w in that spot, minus 6 equals 0. So kind of replaced each one of the e to the x's with w's. So now it really does look a lot more like a nice quadratic equation that we've maybe solved before. The next thing I'd maybe think about doing is seeing, can we factor it? So I'd look at that 6, the constant off to the side, and think to myself, 1 times 6 or 2 times 3 could make 6. We run into a little bit of a problem that we have to subtract here. So we're looking for the pair there that subtracts and makes a 7. Well, 1 and 6 add together to make 7, but they subtract to make either 5 or negative 5. 2 and 3 add together and make 5, but they subtract to make either 1 or negative 1. All right, so we can't really do any factoring in this case. So we have to ask ourselves, what's another option if we can't factor a quadratic equation? Well, a nice option we do have is we could use the quadratic formula. All right, I've gone ahead and listed it off on the right-hand side with w on the left-hand side because w is our variable in this case. So as we get plugging in here, we're going to use a is going to be 1, b is going to be the negative 7, and c is going to be negative 6, just kind of locating the a, b, and c from ax squared plus bx plus c as we've done in the past. Okay, so w is going to go on the left-hand side, and it's going to equal, filling in here, it's going to be the negative of b plus or minus the square root of b squared minus 4 times a times c. And I know it's not interesting watching me plug into a formula, but that's how it goes, all over 2 times a. From here, we just really want to simplify as much as we can. The negative of negative 7 is going to be positive 7, positive or negative, and then negative 7 squared is going to be positive 49. Then we have a negative 4 times positive 1 times negative 6 is going to be a plus 24. We had 2 negatives in there, still all over 2. A little bit of simplifying down and we'll get 7 plus or minus the square root of 73 over 2. All right, so you may be saying, okay, we got our solutions, kind of. Let me go ahead and point out that we found w equals 7 minus a square root of 73 over 2. And we can also say w is equal to the positive case, 7 plus the square root of 73 over 2. But we're not quite done, are we? Right? Originally, we were trying to find x. We found w, but we haven't found x. So what we want to do is go back up to our let statement here when we defined our w, and let's replace w back in with e to the x power. So looking at this, we can put e to the x over on the left-hand side here, equals 7 minus the square root of 73 over 2, and we can put e to the x on the left-hand side here is going to equal 7 plus the square root of 73 over 2. Now we still need to solve each one of these equations down if we can. So how I would approach these is I would apply a natural log to the left-hand side because we have that e to the x power. and I would apply a natural log to the right-hand side as well. 7 minus square root of 73 over 2. Now, why I'm choosing natural log is because that e to the x. Natural log, you'll recall, means log base e. So with that composition, we're going to get really nice simplifying. We're going to get x on the left-hand side all by itself. On the right-hand side for this one, we're going to get natural log. And if I did an approximation for what was on the inside there, this is going to be approximately negative 0.772. So something you may notice on this, we have a negative, right? A negative on the inside of a logarithm, a natural logarithm. So that's not going to produce a solution. You can say this one does not exist. It does not give us a solution. No solution for that one. But what about the right-hand side? If we apply a natural log here, again, because we have e to the x, that'll be on the inside, and a natural log to the right-hand side, 7 plus the square root of 73, all over 2, you'll notice that everything's going to be positive on the inside there. So as we simplify down, we get x equals, that would be the exact solution right here, but we can get an approximation by putting it into our calculator. We can get this to be, let's say, approximately 2.05052 ... keeps going forever as an approximate solution. All right, so just point out, this is our only exact solution. And down here, this is an approximate solution. All right, so I hope this helps out as you're working on some of these more difficult ones where you have to pull out the quadratic formula to help you along the way, even though you're solving down an exponential equation. Hope this helps out. Good luck.